what are some of these specific technologies and how do they work exactly? So I'm not going to go through all of them, but these are the ones that are probably of more interest to you. And so in terms of IoT, we know that IoT is just taking off. And it's taking off because of smart cities. And that's that they want to integrate all the information and everything. Why on earth would you want a smart city? One, you need fewer people. Two, it's going to be more reliable because a machine is always going to be more reliable than a human. And three is save cost. You can run more efficiently. And so we see this big explosion taking place right now. So in terms of data, why do we have an IoT? One is because of the low cost of the semiconductors, so we can have computing. The other is that sensors are so cheap, and we have a way to communicate and bring all this information together. And Dr. Cho was actually working on IoT before there was an IoT. I mean, there wasn't even an internet. And one big challenge we really did have had to do with how are we going to communicate. And now that's been solved because we have the cloud as well as having an internet. And so in terms of IoT, what do people use it for? Well, they use it for control and alerts. That way, all these systems, you don't need people to maintain it. You're going to still need people to react to it, but you don't need as many people as you did before. It allows stakeholders to collaborate, but essentially through all this data, you share it together, and so you can work together. The other thing that drives IoT is the customer experience, that you're using this data to make things better for the customer. Otherwise, why would I want an IoT? In terms of strategy, how does it affect you? And one thing is, if I'm a software company, there's a lot of hardware in IoT. Do I want to get involved with that? And so it's pretty complex. Maybe you have members in your supply chain who are going to handle it for you. Security, anytime you talk about data and control of something, security is an issue. And so somebody hacked into a bunch of wind turbines. You can imagine how that went over. Big data management. Do I use supervised data or unsupervised data? Supervised meaning I'm actually running an experiment and I want to know what it's doing. And unsupervised is, okay, all this data already exists. What does it mean? And so I'm interested in the 5 V's. And probably the most critical V's is veracity. How truthful is it? Volume. How much am I dealing with it? Velocity. How fast can I get it? And also, the biggest thing that people talk about is variety. And the reason why is numbers are much different than words, is much different than images. And what do I mean by words? For example, sarcasm. How do you interpret sarcasm? Glad I would never do that. And the last part are processes. Essentially, now that I have all this capability, how do I transform myself? And that we covered in the last lecture. Blockchain you've heard a lot about, and it's actually not that complex. The idea of the blockchain is originally called a Merkle tree, and the idea is that when you bring all these pieces of information together, it forms its own network, and the network being defined by the top hash. And so concatenation means that I can bring blocks together, and cryptographic means what security am I going to have for it. And so the subblocks are children, and behind the children are your files. So I have all these hashes. What is the definition of blockchain? And what it comes down to is that all this information brought together forms a ledger. And why is that ledger so secure? Because to make any changes, everybody in the chain has to agree to it. And so we'll talk about the logistics of having 10 million users. How do you do that? The way it works is when I talk to a bank or when I talk to a factory, I have to go through somebody. There's going to be some middleman. And so essentially I'm not directly connected to it. Whereas blockchain is peer-to-peer. You are directly connected to the bank. When you're part of the bank's block, in effect, you're part of the bank. Same with the factory and everything else. So the elements in blockchain are the block itself, and that's where you store your transaction data. the parties involved. What you use is a digital signature to protect everybody. And so your digital signature could be your username. Depends. Some people use their real names, some use aliases. Uh, and for every hash, you have to have a unique identifier for it, so it's unique to it. So the process is that first you need some kind of transaction to occur. Not abandoned items, but an actual transaction taking place. Then what happens is the computer verifies the parties involved, and this verification could be thousands to millions of people. The information is stored in a block, and a block is only 1 megabit long, and that's why for one data set you can have thousands of blocks, because you could have gigabit type files. And finally, once a block is verified, meaning everybody in the chain says, okay, it's okay to put this in here, then it's given a hash. In effect, what a hash is a complex math problem that a computer has to solve in order to do the identification. In a sense, you record something, you store it, and you can't edit it without everybody approving it, and that's why it's so pure. You can look at what blocks exist right now and just go to blockchain.com. And you can see what people are doing. The reason why you have security is because you have millions of people with all the same block, and the author can be anonymous if they want to be. But the problem is, if everybody's anonymous, how do I know I can actually trust people? And the idea of a ledger is that every time I add a new block on, or a new user, so I start with A and A plus 1, A plus 2, and so on. If I want to change the block at A plus 1, and I think I can cover it up, the problem is everybody else in the chain has a copy of that block, and so they can show that you monkeyed around with it. And that's why even if a hacker can get back a hash, past the hash, you still have security. And so how does a computer do it? They have consensus models. So 51% of the people in the block agree to do something, then it can happen. What about Bitcoin? Well, Bitcoin is basically what's referred to as a fiat currency. It doesn't actually exist. It's just a value that everybody involved agreed to. Like, for example, we can form a fiat currency and we'll call them Dr. Cho's. So if you have one Dr. Cho, that's equivalent to a quart of milk or something like that. Yeah, it's just arbitrary, but as long as it's consistent, it's fine. And so in order to get through the hash, it's basically solving a complex math problem, which, you have 1 in 7 trillion of getting right. And so, but once you're approved, now I can add a block to the chain. And so this is a lot of work for hackers, and that's why they get discouraged when they see blockchain. They decide not to go after it. So an example is I have a wallet, and what that wallet is it runs my transactions in Bitcoin, and it has private and public information. What a private key is, it's a program in Bitcoin that allows me to run the transactions, and my public key is where I can store and withdraw transactions. The problem is if you lose your key, you've lost your wallet, and now you're talking disaster. And this is why some people put this information on a thumb drive. You lose your thumb drive, it's all over. A consensus protocol means everybody in the chain agrees to a change or adding someone on or whatever. And so you can try to hack it, but you still need 51% of the computers. Now, since these are fiat currencies, can anybody just create any Bitcoin? Yeah, they can. And that's why you have a lot of ICOs, or initial coin offerings. And they're like IPOs. There's over 2,000 currencies out there. 39 of them have more than $1 billion valuation. On the other hand, we have 180 recognized legal tenders around the world. And so there's a video here for you to look at that talks about the dangers of cryptocurrency. So after you watch that video, you get to come back and watch the next one of these.